So on the plank today we have a Samsung monitor, the SyncMaster 223BW, and this is an older monitor that has worked for ages and ages and ages.
The monitor was given to me by a friend after it died. You can see it's plugged in. When you hit the power button, you see a blue light, and that's about it. No image, nothing.
First thing, these three screws need to come out, and the base, I believe, just lifts out. And then there are a couple of screws on the side, two in the corner there, and actually maybe that's all. Alright, so these screws came out, and the base is right here. We've got the three screws right there, and I took the two screws in the corner out, and I believe this should just snap open. So I think the front comes off. On the bezel, front bezel, we've got a plug that I'll just wiggle out, and I'm going to put this aside. That was more difficult than I thought, and this is definitely not the way I got it last time. But now that this is apart, you can see I've got the LCD and the circuit board, which is down there. It's attached by a ribbon cable on that side, and it looks like we've got another power cord or some going on this side. Alright, so now that the back cover is out of the way, we have a fairly heavy-duty shielding here, and notice it does say warning high voltage. This shield, I believe, lifts out, there you go, just like that. And I'll put this aside. By the way, this is the top of the screen, and that's the bottom of the screen. You can see the holes for the mount. It looks like the top and the bottom each have a connector going down to something. I'm going to unplug this. Notice that the pink and yellow are on the top side and the white and black are on the bottom side. I can flip this up here. Alright, so this flipped up this way, and it looks like we've got ourselves a ribbon cable here that attaches to the processor board, and this is going to be the power section, obviously, because the power connector is right there, and I see a huge heatsink right there. My guess is that the LCD is not getting power because something's gone goofy in there, and all this digital processing stuff should be okay, because you saw the laptop, it was trying to connect to it and all that stuff. So again, high voltage, these caps sometimes don't discharge themselves depending on how you design it. So that one really didn't want to come out. The connector had two sides on it that clicks off like that. So I think I'm going to take the single screw that's on this board off. I don't know why there's only one. There's three holes here, but there's no post underneath any of those holes to hold the board up. So it's only held up by one screw there. So unscrew that one. Alright, so that is now off. And this board should be safe to touch for the most part. There are a couple of tabs on the side to keep it in place. That appears, and yep, we've got the connectors here holding them in place, so I guess we have to take these things here off as well. Alright, those screws right there have been removed, and I believe I should be able to just wiggle this out of the corner. Nope, there's one more connector on the side. Oops. Alright, so here's the video processing board. I'm just going to unhook the cable up here, and I'm just going to leave this as is, because this is not going to be the thing that fails. This is going to be the power board. There looks like there's 2 screws that I can see, and no connectors to it anymore. Alright, so all 3 screws have been removed, including that shield that was on top right there. Alright, so we've got the power board here, and let's just take a look at what's going on the board, right? We've got, obviously, the power input right there, and that is going straight into a bunch of filtery things. I see a package, I also get bridge rectifier. This part over here is a switch mode power supply, dedicated PWM chip, and that drives the transformer, and I'm assuming in the output of the transformer you have something lower voltage, and that's going to get filtered through a bunch of different caps here. You've got an inductor sitting in between all this stuff, and pretty much every single one of these caps is bulging on top. So now to see what I mean by these caps are bulging, if you take this and tip it up this way just a bit, you can see just from the reflection that something's gone wrong here, right? The tops have kind of rounded off, and this one has definitely vented some liquid there. These appear all to be 25 volt caps, so you can pretty safely bet that nothing on this side is designed to be higher than 25 volts. One odd thing about this board is the presence of these two pieces of metal onto the board, and here's the back side of the only reason why I could think for this to be here is, well, obviously since it's not over here, and these two halves look relatively symmetrical, it's got to do with the placement of these coils on the board, right? So somehow, being on the axis of this coil, the magnetic field is going to do something weird, probably to the transformer over here, or maybe whatever this IC is. So they decided to put like a screen in front of there. But I'm interested in knowing why they use two of these instead of just one solid shield if it's for shielding, right? There's no reason to separate it into two bits. Unless maybe these were some sort of heat sinks for TO package ICs, and they were just like, oh hey, we've got some on hand, let's just whack them in there. Alright, so here's the underside of the board, and quite nicely they've actually labeled everything for us over here. So I took out C112, which is here, C114 is right there, and C111, which is there. All three turned out to be 820 microfarad capacitors, and they're all bulging. As you can see, they don't quite stand up straight, and they have a tendency to wobble on their end, like that. So, bank capacitors. Alright, so what I want to do now is to plug this into the wall, and then I'm going to probe across the capacitors and see what kind of voltages are present across there, and if it's above, the 25 volt rating, well, there's something else wrong on the board. If not, it might just be the capacitors aged, right? So we can replace the capacitors, and then hopefully it'll work again. Alright, the board is now energized, and that means you gotta be careful with your fingers. And the meter right now is on AC volts, and I'm gonna probe across the input right here. So you got 124 volts. Doesn't seem to be much across there. It's interesting. Let's check C114. Well, that was C114. So across C114 is, looks like nothing across there. Is that like a volt maybe? How about C111? There's 2.7 volts across that. And the last one I took out was this one here. And there is just about nothing across that as well. So, alright, so it turns out that this chip right there is a switching power regulator chip, DM0565. And what it does is it takes the rectified DC voltage over here, and it spits it out in a PWM signal, about 66 kilohertz, and it spits it out across the coil, and then that goes on to power everything else. Right, but the issue is, I don't think this chip is starting up. I probe the ground lead right here, and the VCC pin on there. You can see that it's kind of jumping around quite a bit. And this chip needs a stable 12 volts on this pin to be started up. And there's a startup sequence this chip goes through, and that is going to be started by the high voltage going through here, through these three dropper resistors, and there's an internal current source that will supply the chip with power until the 12 volt DC is established on the VCC right there. And you can see that the voltage, the high voltage side, is jumping around quite a bit, and the VCC is also jumping around as well. So this chip actually takes a on-off switch. There's a circuitry over here somewhere that also ties into this part up there. There's an on-off switch, a soft start, that needs to happen to turn this thing on. And there's an opto right there that is in charge of switching one of these lines on and off. So without this section working, this section isn't going to work either. And when I pulled those caps out, I probably pulled something that this depends on. So what I'll do, since I don't have 820 microfarad capacitors, I'm going to stick in 1000 microfarad capacitors over there. So I don't think anything over here is timing dependent, so 1000 microfarad should work just as fine, given that the voltage rating on the cap is going to be at least 25 volts. So what I've got here is 3 brand new 1000 microfarad electrolytic capacitors from Radio Shack. These are all rated at 35 volts, so that's actually a step up from what was on there, which is 25 volts, which look like these. So these are going to be really good capacitors to be on the board. Also, bonus tip, these packages have a little tear tab on the side, so you tear them, and it opens just like that, and your component will come straight out. Very useful. So these caps are going to go in here. I think these are about the same size. They're a little bit larger, but they should fit in the footprints right there. You gotta make sure your negative's on the negative side, so align that. I'm just gonna push it through. Yep, yeah, looks good. Looks like they're all gonna fit. So, yep, I'm just gonna put these all in and flip the board over, and we'll do the soldering. Okay, so I think these are gonna end up, yeah, being a little bit too big. I'm gonna tag these in on the bottom side by holding it down and just flipping it over like that. There we go. And I'm going to leave the leads in for now, just in case I have to take them back out again. This board just doesn't work, so yep. Really quick job of this. That's 1, 2. Let's check again the supply rail over here. There's 71 volts, no problem. I'll check the VCC pin on here, and that is at a stable 13.8 volts, so let's go ahead and just clip these leads off. I've given board a little bit of time to discharge, and I'm going to clip these a little bit off of the board, so in case, go in here, fix it again. Yeah, that's good. So this leads are going to fly off that way. Go. So that's all installed in there. I'm going to go clean up the solder again a little bit, but first I'm going to put this back into the case and see if this works. Alright, so we have light, but obviously not a picture, so we might have to take those other 2 caps off and fix those also. Alright, so those were the capacitors I just put in, but there are 2 more that are bulging right there, and those also need to get replaced. Alright, so I've got another 2 of these. This is going to be the last of these 1000 microfarad capacitors I have, but that's fine. These are going to go in here, so take them out. So I think I'm going to try one of these solder suckers. This was, until 5 minutes ago, clogged up with solder inside, right there, so I actually took the time, finally cleaned it up, and this should now suck solder again. I've cut this tip off before because it was clogged up. I don't know how solder sticks to this plastic, but it does. You know what, I'll just do this old-fashioned way because this thing is a bit ridiculous. Put a little bit extra solder on here, and I'll just grab hold of the other side. I'll do this leg here first. There we go. Pass it out. There we go, that's the other one. Here's go in this way, so this time there's no clearance issue because we've got plenty of space on the board right there. So those are in the correct way, negative on the colored section of the board. I'll flip that over, and let's tack these what is it, capacitors in. There we go, really quickly. Alright, so the monitor is now plugged in again, and well, what do you know? It looks like we have video, and this screen, what it's showing is the output of my camera, because that's hooked up through the adapter cable on the side of HDMI, VGA, and it's going to be displayed on a screen. So that is working pretty well. Now this is not done yet. I have to go in and replace the other two capacitors that you saw, because those are not bad now, but they're going to go bad in maybe, a couple days for sure. Alright, so these three caps here and those two were replaced by me, and this cap here I think wants to go as well. This cap is 330 microfarads, and I think it's by the same company that made these caps that failed, so this one probably needs to go. This one has the same blue color, so that one wants to go too, but these caps, the smaller caps here, this one, two, and a third one over here, are not going to be taking high voltages, as far as I can see. These are going to be for the optocoupler that's going on over here, so that's going to be seeing only a couple volts here and there. But these high voltage caps probably want to be replaced right now. So I'm just going to worry about this one. I'm going to take this one out and leave the rest in there. And I don't have a 330 microfarad cap, so it's going to be a 220 microfarad cap, because that's what I have. This stuff isn't generally value sensitive because you're in the power stuff, and I put some bigger caps in there, maybe a smaller one would be fine. So just for your reference, that's the back of the package, and that's the front. So go ahead and suck that one out as well, and replace that right now. Alright, so clean up the pads a little bit better, and I can go ahead and put the capacitor in the correct orientation, like that. So these capacitors were the ones that came out of the unit, and before I'm done with this unit, I'm going to go and figure out if these capacitors died open or if they died closed. And I'm going to take a look at what brand these are and do a quick Google on them, because they obviously were not very good. I don't know if you can see that, but I put a little note in here that says which capacitors were in there and what they got replaced with. So if myself or someone else decides to come in here later, there's a record. Alright, just about time to get this off the bench. So let's close this up. And it works. And here are the dead caps that came out of the monitor. Now let's take a look at what these read on the resistance. And that one's reading 685 kilo ohms. And that's not charging the capacitor or anything, that's just that. So this is obviously bad. Well, this one seems to be still okay. Well, it's open. But it's obviously not okay because they got stuff spewing out the top. This one is the one that I removed, even though it didn't look like it was dead, but let's see. Alright, so there's something going on there. 7 megs, so these are all over the place. No two of these are the same. And that one's 26 megs, so okay, that's fine. I'm going to build a signal tracer next, and hopefully we'll get a better sense of what happened to these. And this will be actually a pretty good set of capacitors to be testing with the signal tracer. So that's it for that video, and I'll see you next time.